We'll grab it. Okay, so C1 atoms, elements, etc., etc. Right, okay, so all the elements that are known to man have been placed in a thing called the periodic table. Are we aware of this so far? Okay. Now the periodic table is arranged by the atomic number. Okay. So first of all, we have the periodic table, and it is arranged by the atomic number. Now, the atomic number, if I was to pick something, all right, I'll just pick an element now, and we've kind of, do I want to go with that one? Yeah, I think I'll go with that one. Let me go with the, yeah, why not? If I take this one here, okay, this is a symbol, all right? Now, a symbol is just used to represent an element. Anything in the periodic table is pure. In other words, it contains only those type of atoms. So this is He, which is a symbol for helium. And what that means is that if you find some helium, it only contains helium atoms, all right? Helium is a gas, right? When you get a hot air balloon, or a balloon from McDonald's, all right, it is just full of helium, okay? All that is in that balloon is helium atoms, okay? Because helium is an element. It is pure. It only contains one element, only contains one type of atom. All right? I'm going to go into the atom in a bit, but I'm just going to start here first, right? I need you to also be aware of what these two numbers mean. All right? This bottom number is what I've already mentioned, which is the atomic number. All right? Now, that means how many protons there are in an atom. So in this atom, there are 2 protons. Would you agree with that? It also tells you how many electrons there are. Okay? So by the same token, there are 2 electrons. This other number here, well, this is the mass number. Because there is a third part of the atom called a neutron, and the mass number tells you how many protons and neutrons there are in the nucleus. Now, I'm going to come back and show you that in a minute, but I just want you to be able to grasp that, okay? So the mass number, and I'm going to write here protons plus P and N. Do you know what that means? Are we all right with that? Don't forget you can watch it back. All right, now, I want to draw this element as an atom, okay? But I must have you be aware that if you was to take one balloon filled with helium, it will be full of millions of helium atoms, okay? Now, an atom, all your atoms consist of 3 main components, protons, electrons and neutrons, and they're arranged in a certain way, and you need to be aware of that, all right? So we always call this the structure of the atom. And the structure of the atom has a central part which contains the protons and the neutrons, okay? And I'm going to put a P and a P and an N and an N. Now this overall structure is what we call the nucleus, the centre of the atom, the core of it, okay? And that's where the protons and the neutrons are. Then the electrons we find are located in shells around the nucleus. Now, when I say shell, right, I'm not talking like an eggshell, okay? I'm talking like an energy level, all right? They exist just around the outside of the nucleus, all right? So don't think of, you call it shells in the exam, but just be aware it's more an energy level, okay? But, and I'm going to have to go around here around the outside of the nucleus exist these electrons. Now, we show the electrons in two ways. We either put them as a cross or we put them as a dot, okay? Doesn't really matter, I'll come on to it later on. But I just need you to be aware that these, that's what I'm going to change it for now, are electrons. I'll put a little circle around so realise there's two of them and there's two electrons. Now that is the structure of a helium atom. And you know that just by looking at these two numbers. Alright? Let's look at it again. 2. What does that stand for and what can you see in the diagram? 2 protons, which I can see. 2 also means there's...
2 neutrons.
Does it mean there's 2 neutrons? Does that atomic number... It means there's 2 electrons. The bit that tells you how many neutrons is the mass number, because that is the protons plus the neutrons. And you already know there's 2 protons, so that means there must be 2 more neutrons. Yes or no? Yeah. Alright, great. One more little bit to add on to this before I go any further. Charges. These bits have charges. Alright? They have positivity or negativity. And you need to know which one. There's a nice, easy way. The protons, they are positive in their charge. Okay? They are positive. P for protons, P for positive. The electrons, they are the negative part. No way of remembering that. You just have to do it. But the neutrons, they are neutral or they have no charge. Alright? So protons are positive, neutrons are neutral, or neutrons have no charge. You can do the rest yourself, alright? So that's the way of remembering it. And the only little question you tend to get is about how much they weigh or the mass of them, alright? And I just need you to be aware, alright, that they are neutrons have a mass, that protons also have a mass, hence why they make up this mass number, alright? And we call it 1. Each atom has a mass of 1. Let's not talk what that 1 means, but just call it mass of 1. And the concept is that the electrons, they have almost negligible no mass. Now I don't write no mass, not correct, but tiny mass, very negligible amounts of mass. They don't weigh anything. And it's a classic question where you get the table, protons, neutrons, electrons, and it says charge, and then mass. Alright? You with me so far? Alright, so I'll go back a bit. Electrons, negative, protons, positive, neutrons, no charge.
What's the mass? Oh, would you just put -1?
So, electrons, 0, or very small. -1 would imply it was, it doesn't exist. Alright? So, very small or negligible. Alright with that so far?
Yeah.
Right, great. I'm going to do another one now.